we did say this is an and. This represents what? What does this graph, if you had to say this in plain English, what does this represent? Oh yes, what can it be though?
It can be anything in between 6 and 10.
Exactly. The easiest way to say what this means, these are all numbers between 6 and 10. That's the answer. Any number between 6 and 10, it works. Okay, so plain English. How would we say that? We can say something like, pick a variable and say, okay, 6, 10. Remember the smallest is on the left, the bigger number's on the right. And we would use less than or less than equal to always, right? In this case, since they're open circles, it's less than. So that would be an inequality. The graph appears to highlight all the numbers between 6 and 10. The inequality looks very similar. Your answer is actually physically between 6 and 10. Make sure you only use here, should only be less than or equal to. So they're always pointing to the left, no matter what. If they're pointing to the right, something's off. It's one of those kind of obvious things that if something's wrong, that somebody might put it greater than. So it'll never, ever be greater than. Okay, good. So what we're going to do is just solve, like if you saw in your homework, the 4-year homework problems, the 1 through 10, they had a little bit of solving involved. All we did is just the graphing yesterday. So we're going to do the solving part too. You want to be able to look at a graph and do what we just did. Tell just by looking at a graph if it's an and or is it an or. So there are some context clues that give it away really quick, which you'd want to jot down to make sure you know those as we go through this. All right, we know that compound means to put two things together. We're putting two inequalities together. We have two types of compound inequalities. We have the ors. Oh, sorry, we have the ands right here, and we have the ors where they're pointing away. So with the ands, we only care about where they overlap from here to here. Ors are going in different directions. The biggest difference is that with ands, both inequalities have to be true. With ors, only one of them has to be true at one given time. I'll reiterate that as we go along. Both have to be true, only one has to be true. Here's just a plain example of what you're going to be doing. It looks like your homework question. You'll have an and statement, so one thing you can tell right away. If there is no word here, it's an and. And note how we break it up into two inequalities. So we take this inequality, 4 is less than or equal to x plus 2, solve it. And then we also take this inequality, x plus 2 is less than or equal to 8, and solve that. So you can break it up into two inequalities, solve it, and then at the very end, go ahead and put the answers back together. So we have here 2 less than or equal to x, and here combine this x with this x, same x. So really x is less than or equal to 6. So you can see how I combine these two separate x's into one, and I get my final answer. All the numbers between 2 and 6, and inclusive. Remember that word inclusive from yesterday? It means it includes 2 and 6. That's why they're both less than or equal to. Both less than or equal to. Any of you are writing this down? That's a good thing. You're supposed to do when you take notes. Not just what you see, but what I said, like reiterate what the word inclusive means. Either draw things like, okay, here and here makes that one, and then whatever you need to draw to make it clear on how to break this up. Because on the next page, I'm going to ask you to do this on your own. So you need to have some sort of diagram to follow, some sort of directions you're writing down on how to do it on your own. That's what your notes are, they're directions. If I had to have you do it by yourself, you'd look at your notes and you'd follow them. You don't have to write them the same way I do, just whatever works best for you. And spiral notebook is always a good idea. Big lots, 43 cents. There the whole semester. Okay. Okay, so let's go through one on our own, and then I'll set you guys on try it on your own. Okay, here we go. So break it up. Go ahead and break it up into two parts. There's one. There's the other. We have -5 less than or equal to 2x plus 3. And then 2x plus 3 is less than 9. This right here is the new part for today. After this, it's the same thing. You know how to solve each one of these individually, you know all the steps, and you know how to graph it. So today is really just about that one little part, breaking it up. And then, of course, put it back together at the end. Okay? The nice thing about this, if you write them side by side like this, it is technically an and. If you write them side by side like this, since they both use the 2x plus 3, the algebra is the same for both inequalities. So I can solve these simultaneously at the same time. So I can subtract 3 here, subtract 3 here. It's the same steps for the other inequalities. Subtract 3 here, subtract 3 here. So yeah, you're solving two separate inequalities, but really you're doing the exact same steps. You don't have to figure out, well, what to do on this one and what to do on this one. It's the same. We got this, and because 3's cancel out, 3's cancel out on the left side here, 2x less than 6.
What if there's like a fraction in the middle?
One thing at a time. Get to it. Divide both sides by 2, divide both sides by 2. Again, same algebra, because they're both 2x. The algebra is the same. Both cancel out. -4 less than or equal to our answer. Means -4 is less than all our answers. And here, our answers are all less than 3. So much like we just split it up into two inequalities, let's take our answers and put them back together. So take the -4 less than or equal to x, okay? Then take this part, remember, combine this x with this x, they're the same thing, so really you're just adding on less than 3. So what does this mean? Reading this, just like we did on the very first slide, I want you to be able to understand what this means. Okay? The answer is all numbers between -4 and 3. Nope. Emerging technology. Try it again. It gets confused with numbers and letters. So I have to do and 3. Comma. And then I use the word inclusive. Hello. Inclusive. It's a lazy sentence, just kind of drifts off. So all numbers between -4 and 3 inclusive So it means it includes, oh sorry, negative 4. That's right. Includes negative 4. There you go.
How does it work?
Yeah, it
They
does.
say.
So we got, let's see here. We got negative 4 it includes, but 3 it does not. It's an open circle because there's no line here. And then we know it's an in-between, so we know that they connect. That's what your final graph would look like. Keep in mind, from the very beginning, I already knew that it was going to be one closed and one open, and that it was going to be connecting. I already knew that. All this work right here was just to figure out these two numbers, but the graph was pretty much set just by being able to read it from the very beginning. Closed, open type of graph is an and statement or a between statement, so the graph will look like an and or between graph. Okay. Again, all this is the review part. How to solve it, we've done this before. The only thing new is that very first step, break it up and solve. Okay, or just to break it up, that was the only new part. All right, let's have you guys try. If you prefer, you can use the whiteboards, or you can do this on your paper, one way or another. Please solve it and then check with someone next to you. All right, so what do we get here? Let's see here. Again, I already know that they're both open, so I know it's going to look like this. And I know since this is an and statement, it's going to be connected. So I know all of that about the graph before even starting anything. Just by looking at the same thing over here, I know this is going to be open. I know this one's going to be closed. So a lot of information on your graph before you even start. The solving is just to get, well, what are these two values? What does this one come out to? What does this come out to right here? 1 and 8. Good. And down here? Negative 4 and 2. So as long as you have the work to get you to there. But notice how you get a lot of the answer just by being able to diagnose what kind of problem it is and what it should look like. Everything else is just to get those numbers. Okay. And I went and checked most of yours and they're all great. Okay, so let's look at the other possibility, the ORs. So how do you know it's an OR? It has a big word in the middle, OR. Okay. So jot that down, have a nice example. Notice at the end that you should just have the word OR between your answers. You don't combine them together in any special way like the ands. They just stay one or the other. And that's it. Notice how math is not all about calculation. It's not all about what numbers to use what where, but understanding what's going on, maybe how to write your answer down. We know the graphs go away from each other with OR. And that's 99% of the time. There are exceptions. We'll talk about those at the end.
So if they're separate, then it's just like a separate equation. That's how you set up.
And remember, this is where one of them is true. X can be bigger than 5, or it can be less than 1. It's not both. It's not a number that's greater than 5 and it's less than 1. That's impossible. Just say one of these is true. The answer is here, or it's over here. That's what the word or means. One or the other. The word and means both. Alright, so let's go through the problem and solve it together. Again, let's look at the graph already from the very beginning. Alright, we're going to have a greater than, or a less than or equal to, and a greater than. Okay, so at least I know this. I know there's one solid dot and one open dot. That's as far as I know. You can't really just go down here and put a solid and put an open, because maybe this answer is bigger than this answer, so it would be over here. Remember, these are not going to be in order automatically from smallest to biggest answer. Okay? Like back in the beginning, was where? Here? Now, one of these, the answer, I can't remember what it was. Well, anyway, the answer does not necessarily have to be in that order. Okay, so far they have, but don't count on it always. Okay, so go ahead and solve. Divide, divide. X less than or equal to 3. You have to continue writing the word or. Notice how these are different steps because it's not the same. It's not like a between statement. So x is greater than 4. All right, so we have an open circle and a closed circle. Since 3 is smaller, it's going to be on the left. That's open. And over here, I'm sorry, that's closed. And this one's open. 3, 4. So this says all the numbers less than or equal to 3, all numbers bigger than 4. So basically this is every single number in the whole wide world except the ones between 3 and 4. Say 3 and 4 is, between 3 and 4 is no good, including 4. 4 itself is no good, it's open circle, but every other number is an answer. That's a lot of numbers that are correct answers. Everything except what's between 3 and 4. How many answers are there total that are bigger than 4 and less than or equal to 3? What word would you use to describe that?
Infinite?
Infinite, yeah. Infinite number of answers, because it's every number less than 3 or bigger than 4. That's a lot of numbers. Every decimal, every fraction, every little square root, everything. Okay. How many numbers are between 3 and 4? Here's the kicker. Also an infinite. There's an infinite number of answers that are correct. There's an infinite number of answers between 3 and 4. Because for any 2 numbers you pick inside here, there's also another number between those 2. There's another number between those 2. So it infinitely goes on. So it's weird to think that, well, you feel like there'd be a lot more numbers that are less than 3 and bigger than 4 than the ones just between, but really they're both infinite amount. But that would be your final answer. Okay. So let's have you guys give it a shot now. Same as before, go ahead and try it on the whiteboard or on your notes, but check with someone to make sure they're correct. We'll be walking around to make sure that they are as well. So we do know that these are both closed, so I do know the graph is going to look like this. So this is not about numbers, this is about definitions. Knowing what an OR graph looks like, it looks like that. This is going to be open, and this is going to be closed, and I have one of each here. And assuming, looking at this, it looks like 4, this is going to be what, 4? This is going to be 8. So that one's open, this one's closed, just like that. You have all the work there, you did all the work to prove what the answers are. But you notice I got the graphs almost completed before even starting the work yet. Which one? Oh yeah, thank you. And a very good example of what happens when I don't show the work. Just by that little thing, trying to look at it real fast, got the wrong answer. Yeah, I saw all sorts of things when I was grading quizzes. I saw someone had 6 divided by 3 equals 4. I had someone else that had put 27 in this class. 27 minus 10, and they got 27. You know, so if you're not being careful like I was just right there, not being careful, You rush through it, and I did number, I number all the quizzes as they come in. This person was like a number 8. This is the same person, actually. Number 8. So this person turned their quiz in 8th and had all these mistakes, waited there for 10, 15 minutes, and never thought for a second, I'm not perfect. Maybe I made a mistake. Why don't I just use this time to check, make sure I didn't make any mistakes. Okay? Very good idea. All right. Lastly, this is like number 9 in your book. Okay? That's supposed to be a 9 less than or equal to x minus 10 all over 3 less than or equal to 10. I want to remind you, when you come across a equation to solve and you're not sure how to do it, you don't have to guess. There is a procedure to follow that lets you figure it out. So for this one, you really just have to start off with, okay, 9 is less than or equal to x minus 10 over 3 and x minus 10 over 3 less than or equal to 10. That's the first step. That was the new part for today. But after this, you use the same old steps we did before for solving equations. And if this says, well, this is different, so I don't know what to do, instead of just stopping and say it's different, so therefore I don't know, do the same thing we did before. If you had to plug in a number in here, okay, I'm going to pick anything. I'm going to pick 17. If I plugged in 17 for x, I'd have 17 minus 10 over 3. And if I was simplifying, what would I do first? Starting with 17. What would I do to 17 first? I subtract 10, and then get some answers, and then do what? Divide by 3. Okay, so I'm just listing the order of operations that you would normally do. So for solving, it's just the opposite and the backwards direction. So you see how easy that was to say, okay, yeah, I subtract 10, then I divide by 3. Well, do the opposite. Multiply by 3, and then add 10. There are your steps to solve this, from bottom to top. First you multiply by 3, then you would add 10. So we go here, okay, multiply by 3, both sides, on both of them. Notice how I put the 3 on the top, 3 and 3 over 1, so 3 goes on top. Cancels them both, cancels them both. So we have 27 less than or equal to x minus 10. And we have x minus 10 has to be less than or equal to 10. 30. Thank you. Do something wrong. 10 times 3 is 30. Add 10 to both sides. 37 must be less than or equal to our answers. And our answers also must be less than or equal to 40. Basically, all our answers have to be between 37 and 40 inclusive. So this works for any equation. I don't know how to solve this. Well, what would you do if you plugged in the number, write down the steps? You notice how I don't care about the actual numbers. I care about algebra. I'd subtract 10, subtract 10 on both sides, divide by 3 on both sides. The algebra, not the numbers, what they equal. That's not important. And then just do the reverse direction and then do the opposite. And that gives you your steps of what to do first and what to do second. Okay? Okay, lastly, take a look at that. Why is this a special case? What do I mean by special case? Why is it different from all the other typical problems? X less than 0 and x greater than 7. Yep.
The sign is facing the wrong way.
Well, what does this mean? Nothing's wrong about it, but why is this interpreted different, or why is it weird? Yeah. Okay.
Because x can be less than 0 and
Yeah, you're right. Can't be less than 0 and... Yeah, is there any number that can be less than 0 and bigger than 7? There's no solution here. That's what we mean by a special case. So you notice how the way to understand this was about thinking in real life. Can a number be less than 0 and be bigger than 7? Oh. Okay, so not a math really thing, just have to talk it out and it makes sense. That's what's possible. All right, we'll see you guys tomorrow. Start reviewing for the test.